Hi, I'm Randy Schaup. I'm VP of Engineering at WeWork, and I'm going to talk a little bit about a bunch of incidents that we have had at Google when I worked there, at Stitch Fix when I worked there, and then at WeWork. And what you'll see is a bunch of the details are different, but you'll see a bunch of patterns in how we resolved those incidents, and also patterns in terms of how we ended up improving our engineering practices and our engineering culture going forward after all these things. So again, as I mentioned, I currently work at WeWork with the We logo up there. Previous to WeWork, I was VP of Engineering at a company in the United States called Stitch Fix. It's even hard for me to say as a native speaker, Stitch Fix. It's a clothing company, which you might not be familiar with because it's not yet in Israel, but hopefully sometime soon. The US and the UK, and it's a clothing retailer that uses a bunch of machine learning and data science to figure out the kinds of clothes that people like. Earlier in my career, I spent some time at Google working on the early days of Google Cloud on a product that's called Google App Engine, which I'll talk about in a moment. And then I was a chief engineer at eBay for about 6.5 years early on. Okay, so again, as I mentioned, I want to talk about 3 different incidents, what we learned from them, and how I took the same kind of patterns forward in subsequent companies. So the first story is about an outage that we had in Google App Engine. So this outage was in October 2012, and at the time, it was pretty bad. So Google App Engine, if you're not familiar with it, is what's called a platform as a service. So if you're familiar with, Heroku or Engine Yard or Cloud Foundry, it's that kind of thing. And so at the time, 3 million different applications globally were using App Engine to run their businesses, including at the time Snapchat, a bunch of games like the predecessor to Pokemon Go. Now Spotify uses this technology as well. Anyway, so it was a big deal for it to be down, and it was down for 8 hours globally. So very bad day for me and my team. So the details aren't super important, but the critical idea is that we noticed that there was the increased load on at about 4 a.m. on this particular morning. The on-call engineer executed the standard playbook that we have at Google, which essentially is shutting down a whole data center. So if I could take a step back, like when you're at Google scale, you don't like shut down one machine, you shut down an entire data center because there are tens of them all over the world. So that was a thing that we did. We shut down an entire data center. Unfortunately, by doing that, we didn't have enough serving capacity in the moment to do everything that we needed to do globally. So we had what's called a cascading failure. So one thing would go down, then the next thing, then the next thing, then the next thing. So a pretty bad day for our on-call engineer. But on the plus side, by the time we realized that this was really a big deal, well, we knew it was a big deal, but by the time we realized it was a cascading failure and the only option that we had was shutting the entire world down, it actually only took us 35 minutes to bring the entire world up. So that was pretty cool. We felt good about that. So again, this wasn't great, but we learned a ton. So as we do, we wrote a postmortem. Obviously, we had a very detailed one internally, and almost immediately, though, within 24 hours, we posted something publicly, which you can still read at the link down here. So the first thing that we did was try to fix the immediate problem, right? So the immediate problem was that in that moment, for that particular set of load, we didn't have sufficient capacity globally to serve everything that we needed to do. So we increased the capacity then. Okay, that's great. That solves like the micro problem. But more importantly, and that's what I'm going to talk about for this talk, is we ended up spinning up a whole program of multiple projects to improve our reliability and sort of resilience to these types of failures going forward. And so I led this effort, and so that's what I'm going to talk about. And just to telegraph a little bit, the wonderful experience that I had running this program at App Engine caused me to kind of execute that same playbook at Stitch Fix and then later at WeWork. Okay, so let's talk about what that program was. So in Google speak, we called it the reliability Fixit. So we were trying to fix some issues that had accumulated over time, many issues that had accumulated over time around the reliability of the system, and we wanted to fix it. So we had a bunch of steps that we went through. So the first step was to really identify all the problems that went into reliability issues. So the way that we did this in practice is we sort of did a brainstorming session where we got all the technical leads and the senior engineers in one physical room. We had a whiteboard. Actually, we had the room was like covered in whiteboards on 3 or 4 sides, and we spent an hour or two filling those whiteboards, and I mean filling them with all of the ideas, some that we knew about and some that we only suspected, about things that could contribute to various aspects of reliability issues. So we enumerated all of those things, and what we realized is that we'd accumulated a lot of what we call technical debt, and we hadn't been prioritizing those reliability issues as much as, in retrospect, we hoped we had done. We bucketed those, after that brainstorming session, which was very free form, we bucketed those issues into what we called 8 or 10 themes. And so each of those themes we assigned, or somebody volunteered in that room. So one of the senior engineers volunteered to take each of those sort of 8 or 10 themes, and we said, okay, here's what we're going to do. John or Susan, Susan, you're going to take this particular theme in 1 week. So spend a week working on it, fleshing it out, thinking about the issues, trying to research them, make some proposals, and we're going to come back in 1 week all together, essentially into this same room, talk about the things that you found and the suggestions that you have, and then we're going to prioritize them and start working on them. So again, the key thing was that we gave those people, that we did the brainstorming to get all the stuff out of people's heads. We gave them a week to think about, to do some research and to learn more in detail about those ideas and to come up with with good suggestions. And after 1 week, all of those leads came back, and they had a detailed list of issues. Each issue had, a recommendation. We didn't ask them to do like a full design or anything, but sort of a one-line, we should do, this type of thing or look into this thing. And the key thing to make this low stress but high value was just not to have a big estimation about how much that thing was going to cost, but just sort of an estimated, I called it an order of magnitude. So, all right, Susan, do you think that this suggestion is going to take 1 week or 1 day, 1 week, 1 month, 1 quarter, 1 year to fix? Does it make sense what I'm suggesting? A sort of order of magnitude, like off the top of your head estimate. And the idea was, again, to just get in the ballpark to see, what kind of thing we were talking about. Okay, so into that meeting that we had a week later was all these kind of lists of proposed projects. Okay, so now, obviously there was more on that list that more to do than we had time to do in the moment, right? So we needed to discuss and prioritize among those things altogether. And one of the critical things was to do this as a group, as distinct from having, one fancy leader, which would have been me, make myself all the decisions. So the leads discussed all the themes, we prioritized those all together, and then we got to work. So then we said, all right, of the, I'm making this number up, 100 things that we decided to do, we're going to start on, these 5, and let's assign engineers to them and get moving. Okay, so now we're in the phase where we're actually doing a bunch of those things, and so we had engineers working on those individual tasks, and from a management perspective, this was a very low, this is very high value, low stress, low investment for me, because basically our tracking thing was a Google spreadsheet where each one of those little projects or little sub tasks was just one line in this spreadsheet, and every week I asked the engineer that was working on that to update how far she had gotten. So very minimal effort from me. It took me about 1 hour every week to send the reminder emails, hey Susan, could you let me know what you're working on, and that sort of thing. And then we summarized the progress that we were making every week in the standard kind of weekly all hands that we all had globally in App Engine. Does it make sense what I'm saying? Cool. The results were pretty impressive. Way more impressive. My team did all the work, of course, but I was really, really pleasantly surprised at the amount of progress we were able to make. So obviously the goal of this was to reduce the amount of reliability issues that we had. So we did get about a 10x reduction in ongoing issues in reliability. So that was the first order thing that we wanted to achieve. But even more importantly, for the long-term health of this idea, and the thing that made me even prouder is that by focusing on these issues, we actually got a much more kind of team cohesion. People were really excited to work on these things that they felt like were really important to the health of the product. And when this is 7 years ago, and when I meet with friends of mine that, my continued friends that I used to work with there, they still remember this. So they still talk about, wow, wasn't that reliability Fixit great? That really kind of shifted the mindset of our entire team. So really feel good about that. Okay, so the next place that I worked, I think that was the next place that I worked after Google, a couple of places later. So company Stitch Fix that I mentioned. So in 2016, Stitch Fix was having a bunch of reliability issues as well. The details were very different from Google, but we executed, as you'll see, the same playbook. So the details here aren't very important. This is sort of an internal list of issues that we had accumulated. Just notice that there are lots of dates all together in October and November of 2016. And notice that there's a lot of red, which is shared database. So Stitch Fix's architecture at the time was that there were a bunch of different applications and services all using one monolithic shared database. And it turns out that when you have a single point of failure like that, a single performance bottleneck, a single place of reliability issues, that if the shared database had a bad day, everybody had a bad day. Okay, so we needed to improve the stability of that database. In particular, some of the problems that we identified were a bunch of applications were all contending on the same common tables in that database, so they were slowing each other down, locking each other out. Scalability was limited, but we had a limited number of database connections that we could use across all the applications and services, and our applications and services were contending on that shared resource of those connections, and then one application could take down the entire company. So we executed essentially the same playbook where, again, we got everybody together. In this case, it was virtually in the same room. We identified the problem, brainstormed all the issues. Again, we tried to understand the problem. We had people assigned to those themes, similar to the Google outage. We gave people a week or two to think through the details, come back with recommendations. We came to a consensus and a set of prioritization decisions about what things we would take forward, and then we did a same kind of simple implementation and follow-up. And again, we got really great results. One of the parts of this thing that we did was actually working on breaking up that monolithic database. So again, in details, we were focusing on the particularly expensive queries that were causing a lot of stress on the shared database. We figured out a way to manage those database connections through a connection concentrator so that we were able to provide more connections to the applications and services that were using that shared database. And then we also executed what I called the stability and scalability program, where we invested an ongoing about 25% of engineering resources, mostly on trying to extract things out of that shared database so things could move more independently, like Kevin Goldsmith said in our early keynote. Does this make sense? Great. Okay. So the last thing in the pattern that I want to tell you today, the last kind of story is about WeWork. So recently, our issue was that members were finding it difficult. Well, we're having issues logging into our website and our mobile apps that my team builds. One of the things that we determined from investigating that situation was that we actually had a bunch of different back-end systems that had different representations of what users were allowed to do, and they were in conflict with each other, and that was one of the contributing factors to these login issues. And just more generally, over time, we started with a small startup moving very quickly, and a bunch of interactions between the systems that started out very simple became more and more complicated and more convoluted over time. Has anybody had a similar experience at a place that they've worked? Come on. All right, only a few hands went up, but I don't believe you. Cool. And then also we didn't have enough what I would call graceful degradation or automated repair for some of those issues. Okay, so again, we did a same kind of retrospective. We identified the problem with everybody in a room. We tried to understand the problem, bucket it into particular themes. We prioritized the things that we needed to work on, some short-term and some long-term, and then we're right now in the process of implementing and following up on all those things. And so I will show the results thing maybe next year when we're finished with a bunch of the things that we're working on. So there are a bunch of common themes here, and so I want to, in the kind of second half of this talk, I want to talk about those common themes and in particularly walk through three sets of themes that I think you can maybe take away to use in your own organizations. So one of the common elements across all of these three outages was an unintentional kind of long-term accumulation of what I call small, individually reasonable decisions, right? So individually, we're making a reasonable decision about prioritizing maybe a short-term feature over a longer-term reliability. This is a legitimate trade-off that you can make either way, but slowly the accumulation of a bunch of those things had large systemic effects. Something that the safety community calls a compelling event. So in the App Engine case, the 8-hour global outage. In the Stitch Fix case, for the 1 or 2 months, like the database going down all the time. In the WeWork case, login issues. There was some compelling event that made everybody kind of wake up and go, wow, we really need to pay attention to some of these things. And that compelling event was a catalyst, like in chemistry, a catalyst for long-term change that had long effects on the organization going forward. One of the things in all three of these cases that made it possible for us to go through those solutions is blameless culture. Like, people have probably heard of this idea of a blameless postmortem. So postmortem is a thing you do, in medicine when somebody's died. You try to figure out why they died. That's the mortem part. No people died, as far as I know, as a consequence of any of these software decisions. But the idea of being blameless about it, where let's just understand the facts, understand what happened, and then we can use that as a learning mechanism to go forward. And then the other thing is what I went through, the sort of pattern or playbook that I executed several times, what I call a structured approach to this kind of post-incident improvement. Okay. The other thing I want to be very clear about is all of these cases work from legitimate, reasonable technology decisions going forward. So it's not like, oh, we had this outage, that means we were terrible people before, right? That is not the lesson to take away. It's we made reasonable decisions, but now the implications of those decisions, because maybe the context is different or the load is different or something like that. So the way I like to think about this is, particularly when you have gone from a startup to a more scalable company, if you don't end up regretting your early technology decisions, you probably over-engineered. Does that make sense what I'm saying? Like, if you made the perfect system, so I used to work at eBay. eBay started in 1995. If eBay spent all its time in 1995 building some perfect, highly reliable distributed system, they would have spent all their effort doing that and never would have been successful, right? So it's possible that there's an eBay or Amazon competitor in 1995 that instead of building a horrible monolith but like getting going, instead they built this beautiful, perfect system. There is a reason why we have never heard of that company. Yeah? Great. Okay. So I want to spend maybe the next 10 minutes, the final 10 minutes of the talk, talking about some lessons that we as leaders can take away. So the first thing I want to talk about is leadership and collaboration, how that's really important to recovering from these issues. I want to talk about quality and discipline, which is some of the things that when you're a higher scale, larger company, you do have to end up putting in place. Things that were inappropriate when you were small, but become very appropriate when you are large. And then I want to give some suggestions about how we as leaders can help to drive that systemic change in our organizations and in our technology. So let's start with leadership and collaboration. So I mentioned the idea of the blameless postmortem. I'm going to talk a little bit in detail about what I mean. So again, we've had some incident or some outage that we wish we hadn't. The important thing is that we have an open and honest discussion with all the stakeholders about what happened. We think about, well, how could we have detected this thing earlier? How could we have diagnosed it more quickly? How could we have mitigated it? How could we have remediated it? And maybe how could we have prevented it altogether? And if we do an open and honest discussion here, if it is open and honest and blameless, then I have seen so many times the engineers in the room almost compete to take personal responsibility. So somebody will say, oh, you think you guys were bad? Well, we weren't even taking backups and our replication wasn't working. And when you observe it, and as I have now observed this 3 separate times, it seems a little bit crazy. Like, why would people raise their hands and say, oh, no, I was worse than you guys, come on. And here is the place in the engineer's heart where this comes from. It comes from this place. They say something like, finally, Randy and the senior leadership are going to give me the priority to fix this thing that I knew was broken all along. Any engineers in the room that have sometimes felt like this? Yeah, let the record show that many hands went up. Yeah, this is what this feeling is like one of the great engineer feelings in the world, right? Not feeling the terrible part, but this idea that I see this system that is broken and in my heart I want to make it better. That is the place where you get that kind of competition for, which team was worse in this thing. And I love that. And again, that only happens when you bring engineers into the room and you make it open and honest and free and blameless, right? That is the safe place that allows this conversation to happen. Can't emphasize that enough. Okay, so the next thing, once we've gotten all those things out, is let's collaborate on them. And in my experience, the best decisions, the prioritization decisions that we make are best made in partnership with not just the engineers in the room, but the product people and the business people and all the stakeholders. And the critical thing that I have found is that it's very important for all those teams, all those people in the room to share context. So for the people in the room, I hope everybody, who saw Kevin Goldsmith's keynote this morning, one of the things he said was a critical element into making autonomous teams work is the sharing of context, right? Communication and context. And this is the place where, this is the opportunity that we have to share all the context about why things have happened and what the implications are. And sometimes it's possible, well, it's often possible that we don't always agree. Usually I think well-meaning people with shared context do agree, maybe 80% or 90% of the way, or at least culturally where I'm from. But when that is not the case, I love this Intel idea of disagree and commit. So the idea is, look, we've had a transparent conversation about all the things. Everybody understands the common context. Here is the consensus decision. Even if I don't agree, I commit to making it successful. Right? I commit to not, undermine it or continue to, make my counter arguments, blah, blah, blah. It's like, okay, the team decided we're going to do X. I'm fully on board with doing X. Okay, great. The other aspect is this wonderful Churchill quote, which is, never let a good crisis go to waste. So again, this is the compelling event. Right? So we have had this, in all these cases, there was a long-term accumulation of small individual decisions which had large systemic effects. And when that crisis happens, it's important as leaders that we use that as a catalyst for change. Does it make sense? Not exploit it, but use it like, hey, we were down, like our customers are unhappy with us. So it's our job to make sure that we do better by them next time. That is our job. Okay, cool. So that was leadership and collaboration. Now I'd like to talk about quality and discipline. So the way I like to think about it is that quality and reliability of the software that we produce are actually business concerns. It is not, it is unhealthy and dysfunctional, in my opinion, to have organizations where engineering cares about quality and reliability and business cares about features and neither of them cares about the other. Like, we should both be caring about producing good features for our customers, but also producing those features reliably and consistently, et cetera. Who has ever heard this? We don't have time to do it right. Let the record show that there was knowing laughter and most hands went up. Okay, here is the thing that you can say. You can say, do we have time to do it twice? That's the choice. That's the choice. And I don't mean right like perfect. I don't mean trying to do it perfect the first time, but I mean do it solidly, minimal viable product, minimal viable feature, do something solidly so you can be done with it, at least for the moment, and then move on to the next thing. And the reason why I say it in that way is, and I've experienced this as a startup co-founder and other things, is Crazily enough, the more constrained we are with time and resources, sometimes the more important it is to build it right the first time. Why? It's because we have so little time and so few people that we can't afford to like keep going back and fixing the old broken thing and fixing the old broken thing. Does it make sense? Again, what I do not suggest is that we build something perfect, that we build something just good enough that we can leave it to the side, and then we can work on the next thing and the next thing and the next thing. Great. I'm not the only person who says something like this. Steve Jobs, who was referred to in the previous wonderful talk, has this idea. Don't try to do everything, but do one thing well. Yeah? Great. A tool that can help us, certainly that comes out of the Agile community, is this idea of definition of done. So a thing that we've done with my teams at WeWork now is be very clear about what we mean when we say we're done doing a feature. And again, done doesn't mean perfect, but it means what does it mean for us to be done for the moment, set it aside. So let's build the feature in the most minimal viable way. So minimal, it does just what it needs to do. Viable in the sense that we can actually leave it. It's going to be reliable and good quality and so on. That we do automated tests. That we release that thing to production. So I don't know how many times I've talked to engineers over in the past and say, oh, are you done with that thing? Oh yeah, I'm done. Is it on the site yet? Oh no, we haven't released it yet. Like, okay, you're not done. And people are probably familiar with this idea of feature flags or feature gates. So we do use those very extensively at WeWork. Actually, in all the companies that I mentioned, we use those techniques very extensively. So I've also had this conversation. We're like, okay, your thing's out on the site. Is it done? Yes. It's out on the site? Yes. Did we turn on the flag to have the customer see it? Oh no, product manager hasn't done that yet. Okay, dude, you're not done. Still not done. And then the other thing is that we need it to be sustainable for the team, so we want to be able to monitor it. Does it make sense? And the point behind this is that we are not done until the business and the customers are getting value. Like, not done, everything's a waste until we produce that value, ultimately show it to customers and give it to the business. Great. So what we're trying to do in this section is we're trying to take the past, where we made legitimate decisions. So we did things quick and dirty. We accumulated some technical debt. We didn't have time to do it right. We went round and round and made things worse over time. So a vicious cycle of technical debt. And what we want to do is we want to change it to something that looks more like this, where we invest in quality. We have a solid foundation. It gives us the confidence to maybe radically refactor things when we need to do that. We get faster. We get leaner. We get better. We have more ability and resources to make more investments in quality, and we actually turn that cycle around to a virtuous cycle rather than a vicious one. So the last set of lessons I want to talk about is around driving change. Every time I have seen change work successfully in a company, it is because it is both motivated from the bottom, but also permitted/encouraged from the top. So I do not think that large systemic change can happen in organizations without the combination of top-down and bottom-up. Nowadays, I'm the top-down, so like I have to help to encourage my teams, give them the goals, give them the encouragement to make these things. But the teams also have to be able to do it themselves. If you have top-down without bottom-up, that's every one of those horrible enterprise-y things that we all roll our eyes at, right? Okay, yet another quality improvement program, blah. But bottom up without top down is every one of those, man, we really want to try to do this, but management won't let us. Does it make sense? The only way we're going to get change is both. Okay, very briefly for the leaders in the room, how are we going to fund one of these long-term projects? So I can see two ways. One way is you can just fold these reliability or long-term improvements into the standard projects that we do. That works well if and only if the work that we need to do is scoped within the boundary of the team. Does it make sense what I'm saying? So teams are producing features, hopefully in an autonomous way. If we can make long-term improvements within the scope of the team, we can absolutely fold it into the team's work. But it is common that these big deal things are not possible to do within the scope of one team. They actually, to have an effect, they actually have to be done across lots of different teams. And what I have found is the best way to do that, or a really good way to do that, is to agree at the leadership level on some overall global investment that we're going to make in the improvements, in reliability and stability improvements overall. So we might decide, I'm making these numbers up, but they're the numbers that I've used in the past. Maybe at this point we need to dedicate 25% or 30% of resources to making these long-term architectural and systemic improvements. And this is a good way of doing it when the improvements need to be done across a bunch of different teams. Does it make sense? Here's a little trick that I've learned. An unexpected ally in this conversation is actually the finance team. You're like, why? Because engineers are trained to do risk assessments and try to think carefully about the implications of decisions. This is also true of the finance people. So anybody who has done finance has thought about option value, has thought about risk mitigation. Like, part of the job of the finance person, particularly when you're in the public market, is to think about bad things that might happen and estimate the risk and the cost of those things and mitigate against them. Does it make sense what I'm saying? So even though I am not trained as a finance person, believe me, the finance people are typically not trained as engineers, but we have a very compatible way of looking at the problem, and it turns out that for those people that are neither trained as engineers nor trained in risk assessment like finance, we can kind of surround them a little bit. Does it make sense what I'm saying? Cool. Okay. So what we talked about was, we talked about leadership and collaboration, we talked about quality and discipline, and we talked about driving change. And I'll leave you with this wonderful quote from Martin Fowler. So a bunch of us don't work yet in organizations that do this kind of stuff. And I love this quote, which is, if you can't change your organization, you can change your organization. So totally independent of that, I will point out that WeWork, where I work, is hiring. We do have actually 850 software engineers globally, headquartered in New York, but immediately after New York, the largest number of people, approaching 200 now, in the technology organization, are actually right here in Tel Aviv. So thank you very much.